So here's a different type of trig equation than we're used to seeing. This one is a rational trig equation. In other words, it's a bunch of fractions with trig expressions in the fractions. Now you can solve this the same way you solve any rational equation for starters. We need to get rid of the fractions. So I'm going to start by just putting this equation right here. 1 minus 2 sine omega over cosine omega equals cosine omega over 1 plus sine omega. And if you like getting common denominators and then crossing out the entire bottom, that's fine. But that technique is basically, this is what we're doing. We're multiplying both sides of the equation by cosine in order to cancel out these cosine terms. And we're also multiplying the entire equation by 1 plus sine omega in order to cancel out the denominator on the right side. So we need to multiply the whole equation by those two things. And once we do that, here's what we get. You might have heard of this technique as cross-multiplying. Okay, that's another thing we refer to it as. You get the fraction on the left with the cosines canceled out, and it's also times the denominator from the right. 1 plus, not 2 sine, that's just 1 plus sine omega. And the fraction on the right has its denominator canceled out, and that just becomes cosine omega times cosine omega. Okay, so the reason why it's called cross multiplication is you could also think about it this way. Let me get all this stuff gone. You could also think about it as the denominators cross multiplying, like that. And if you prefer that, go for it. That's a perfectly good way to think about it. There we go. Okay, so here's our equation, and now we just need to FOIL the left side, or if you prefer to distribute your multiplication, that's fine. Either one works. This is going to be 1. Looks like that's minus sine omega overall, and then minus 2 sine squared omega. Okay, and then on the right side, I have cosine squared omega. Now we're running into a problem. I want to factor this. I want to get it in factored form, looking like this little thing. Okay, some parentheses times another parentheses equals 0, easy to solve. But I can't because there's no GCF here, right? I've got cosine over there, sine over here. There's no GCF in between them. And any kind of factoring you do is basically not going to work. What we need to do at this point is reach into our trig identities bag of tricks. And now it comes down to selecting the correct identity. So take a look at what I have down here and look back at those identities. You can pause the video here, see if you can figure it out. But I'm going to tell you that double angles is probably not the way to go. I'm not saying definitively, but probably not, because these angles are all single angles. Now, that's really not a rule. It's just more of a hint. We could still make double identities work here if we wanted. But let's go for something else. Since there's squared terms right here, that's a hint that maybe we should try the Pythagorean identity. Okay, so I'm going to go for that. And the one that I'm going to choose is a cosine squared identity because I already have sines everywhere. And if I could just change this guy to a sine of some kind, I would be able to solve, or hopefully I would be able to factor this thing. So this is going to turn into 1 minus sine omega minus 2 sine squared omega equals, here's the substitution, 1 minus sine squared omega. Right, we're using that Santa Claus trig identity, this guy right here. Sine squared plus cosine squared equals 1. Okay, so now collect all your terms onto one side. I'm going to choose to add 2 sine squared to each side because I have a very strong personal preference for having my quadratic terms be positive. It helps me avoid mistakes. And I'm going to subtract 1 from each side, and I'm going to add sine omega to each side. So let's see what we get. We're going to add all this stuff up. On the left, we get 0. Okay. On the right side, we get what? Let's see. Hold on. Computer running out of batteries. We get, let's see, 1 minus 1 is 0 on those guys. And then we just have sine squared, negative sine squared plus 2 sine squared. That's going to be a positive sine squared omega. And then I still have this guy, the plus sine omega. So that's where we get after combining all like terms. And you just go a little further, and I can pull out a GCF and sine omega plus 1. So now we have two solutions here. One of them is that sine omega equals 0, and the other is that sine omega equals -1. So if you think about your unit circle, what are these angles? Well, sine is the y-coordinate. So either we have the y-coordinate equals 0, or the y-coordinate equals -1. So here are those angles. 0 degrees, or 0 radians, pi radians, and 3 pi over 2 radians. And now what you have to do, we're not done yet. You can't just put a box around this and call it good. We have to go back to that original equation and just check any domain restrictions. So what are our domain restrictions here? There's one. Cosine omega cannot be 0. If it is 0, then you're dividing by 0, and that's really not good. And here's another one. 1 plus sine omega cannot be 0, which means sine omega cannot be -1. Uh-oh, that's one of the ones we had here, right? Sine omega equals -1. So we're going to have to deal with that. And let's even be a little more clear about these domain restrictions. Let's put these in terms of angles that are not allowed. The angle cannot be pi over 2 or 3 pi over 2, because that would lead to cosine equals to 0. And the angle, furthermore, cannot be -1. That's going to be 3 pi over 2 also. So here are our angles to avoid. Pi over 2 and 3 pi over 2. And there it is. There's one of them right there, 3 pi over 2. So that one is extraneous. If you solved this problem and you were wondering why one of your answers was not actually one of the real answers, that might be it. So there we go.